Okay. Good evening. We're going to start with the states of matter. States of matter. The first question obviously comes is that what is matter? All of us know this. It's nothing new for us. Okay. What is matter? Which has got certain amount of mass and which occupies the space. Okay. So all of us know this, and the states of matter means depending on the states, the matter can be subdivided, mainly I should say, but we have to know in the three different states, right? All of us know this. This is nothing new I am saying. One is solid, one is liquid, and obviously the other is gas or gaseous you can write, okay? So solids, liquids and gases. Now, why something is solid, why something is liquid, why something is gaseous, that we know. Means we know the properties of them. Clear? Suppose this pen I am holding is solid. We know this. A glass of water is liquid. Now, why it is liquid or why the gas is solid? Gas is gas and solid is solid. Okay? That is determined by what? That is determined just by two factors. All these things you know, it's nothing new I am saying. Once again I am saying, this is determined by just two factors. Okay? And what are the two factors? The first one is intermolecular space. Intermolecular space. Yes. In case of solid, the intermolecular space is very less. Okay, don't write anything. I will tell you. Then you will write. Okay. Intermolecular space is very less. They are very tightly packed. That is why they are solids, and that is why they are showing the properties of the solids which we see. In case of gases, the intermolecular space is very large. They are far apart from each other. Suppose this here is the gas. Yes, through which I can move. Through solid, this wall, through solid I cannot move. Why I cannot move? Because the intermolecular space over here is very, very less, means they are very tightly packed. Okay? And in case of liquid, it is moderate. Through liquid you can move, but you will feel, right? Suppose some water is there, some water is falling through which we can move. We have to spread the water and we can move. But you will, that means what? That means you are feeling that water is there. Means intermolecular space is there, but that is not that small, neither as big as that of the gases. We know this. Now, why the intermolecular space is in certain cases it is small, in certain cases it is big, in certain cases it is in between, we call it moderate. Okay? That's because of the second factor. That's because of the second factor, and that is called intermolecular force of attraction. Intermolecular force of attraction. All this, it's not that you don't know it. Okay? All of you know it. Intermolecular force of attraction. Okay? Those molecules that is present in the substance are attracting each other, right? Okay? If the force of attraction is very high, the space between them will be very less. And if the force of attraction is less, the space between them will be more. So in case of solid, what is the intermolecular force of attraction? The intermolecular force of attraction is very, very high. In case of solid, intermolecular force of attraction is very high. That is why, since it is very high, so the intermolecular space will be less. Okay? Intermolecular space less, that is why it is showing all the properties which you see in case of solid. It has got definite shape, definite volume, etc., etc. You know it. Okay? But in case of gases, the intermolecular force of attraction is very less. That is why they are not coming closer to each other. They are far apart from each other. And in case of liquid, again it is moderate. The term I am using moderate means it is neither very strong nor very weak. Is it clear? Understood that? Okay, so this is the basic part all of us know. But here, though the name of the chapter is states of matter, we are going to study in our syllabus only gas is there. Only gas is there. Okay, so we are going to study gas, and that also the basics of the gases. The solids, we are going to study the first chapter in class 12, and the liquids in terms of solution actually we are going to study in the second chapter of class 12. Okay, so here mainly we are going to focus on the gases. Okay, now first you write down this whatever you wrote. Right, a matter is a substance. A matter is a substance. A matter is a substance which occupies some space, and has some mass, full stop. They can be classified in three types. Number A, solids. Number B, liquids. And number C, gases. Right? Okay? The variation in the properties will be the variation of the properties.
What time will it be over?
8:30.
8:30. And please tell us the dates and all everything.
Yes. Oh, Anna. Because we never met each other, na? That's the right. Okay. And the variation of these properties will depend on mainly two factors. Number one, intermolecular space. Intermolecular space. Okay, give a dash and write. This is the space between the particles present in a substance. Full stop. Its maximum in case of gases. Its maximum in case of gases, and is minimum in case of solids, and minimum in case of solids, right? Intermolecular space, okay, and minimum in case of solid, okay, fine, okay. It is moderate in case of liquid. Full stop. Then number 2 and number B, whatever you write. Intermolecular force of attraction. Okay. Give a dash and write. The intermolecular space depends on the intermolecular force of attraction. The intermolecular space depends on the intermolecular force of attraction. Full stop. More the intermolecular force of attraction, less is the intermolecular space. More the intermolecular force of attraction, less is the intermolecular space. Full stop. Therefore, solid exhibits maximum intermolecular force of attraction, and gas exhibits minimum intermolecular force of attraction. Full stop. The intermolecular force of attraction in liquid, the intermolecular force of attraction in liquid is moderate, So this is the basic part which all of us know. I didn't teach you till now. I hope I didn't teach you anything new, right? You knew all these things, okay? Now we are going to go into the detail of it. Obviously we are going to study the gases, as I told, only the gases. Now, first thing we are going to do is that intermolecular force of attraction. What is intermolecular force of attraction and what are the types of intermolecular force of attraction? Okay, so you just give a subheading and write it down, or give a heading rather. You can write types of intermolecular force of attraction. Types of intermolecular force of attraction. Types of intermolecular force of attraction. Okay. Anna, you keep some space. How much is there? Just keep some space before that. Okay, little bit. That is the the easier part and the basic part I told. Okay. Types of intermolecular force of attraction. Okay, that's the heading. Okay. Now, what is the nature of the intermolecular force of attraction? That depends on. Don't write anything. I will tell you. That depends on what are the particles. What particles are present? It is depending on that. There are different types of intermolecular forces of attraction. Some are strong, some are weak, some are moderate. Okay. Now, what are these actually? Okay. So the different types of intermolecular force of attraction is, just let me write first, then you will write. But let me explain, then you will write. The first one is dipole-dipole interaction. The first one is dipole-dipole interaction. Please understand it. Dipole-dipole interaction. Okay, that is the first one. Suppose, don't write anything. Okay, dipole-dipole interaction is the first one. Okay, what is dipole-dipole interaction? Suppose we are talking of H2O in any state. H2O. Okay, it can be solid, liquid, gas. Okay, so H2O, all of us know the structure of H2O. H, O, H. You know this? Yes? Okay. So I'm writing it in this manner. You can write it in any way. It is V-shaped. We know it. Okay? Another molecule of H2. I'm just writing over here. Suppose O, H, H. You can write in any form. Suppose it's oriented in this direction. It's oriented in this direction. And what else we know? That oxygen is highly electronegative and hydrogen is highly electropositive. Right? So because of its electronegativity, that we know that this is delta negative, this is delta positive. We have studied this, right? This is delta positive. Same way, this is delta positive, this is delta positive, this is delta negative. Means this molecule is a polar molecule. Do you know that? This is a polar molecule. A dipole moment, a resultant dipole moment is there. This molecule is also a polar molecule. So these particles present in the substance are polar in nature. Okay, fine. So this will attract each other. Suppose this negative will attract this positive. This positive will attract this negative. The force of attraction will be there. And force of attraction is because of what? Because of two polar molecules. Two polar molecules are attracting each other. So if the force of attraction is between the two polar molecules, then that force of attraction is called obviously what? You can understand from the word itself, dipole interaction. Both has got dipole moment. Okay? Obviously, both has got means what we are talking of. If we are talking of one solid substance, that particular solid substance, if it is polar, then they will exhibit what? They will exhibit the dipole-dipole interaction. That's the first type. I hope it is clear, right? Dipole-dipole interaction. The second type, dipole-induced dipole interaction. Dipole-induced dipole interaction. Dipole-induced dipole interaction. Induced dipole interaction. What is dipole-induced dipole interaction? From the word itself you can understand. One of the molecules, out of the two molecules which are attracting each other, one of the molecules must be polar. Okay? Suppose I am taking the same example of water. Okay? H, H, O. Okay? Fine. So this is O negative, you know. This is delta positive, delta positive. Yes? Okay? Fine. Another molecule I am taking, suppose a non-polar molecule, suppose solid carbon dioxide or gaseous carbon dioxide, whatever. This is water vapor, okay, and gaseous carbon dioxide. Carbon dioxide, all of us know that this is C double bond, CO, C, double bond, O. It's a linear structure. I'm just writing it in this manner. You can write it in any way. Okay, and it does not have any polarity. It is just a non-polar molecule. That also we know. Okay, let me write it like this. Then it will be easier for you to understand. So O, double bond C, double bond O. It's a non-polar molecule. Okay. Now what is this? This is negatively charged. This is negatively charged. Now it is coming closer to this molecule. Coming closer to this molecule. Okay. If it comes closer to this molecule, since oxygen is approaching towards it, this negative charge will repel the electron, bonded pair of electron here, this bonded pair of electrons little towards carbon. It will just repel, since the negative charge is coming, the bonded pair of electrons means what? This is a negative charge only. This negative charge will be repelled little bit towards away from this. Will it be repelled or not? Suppose this is a negative charge. This is a negative charge. In a molecule, this is a negative charge. Or this is neutral. Suppose this is neutral and another molecule is coming which is polar. And this black part is negative. Clear? So if it is approaching over here, the electron that is present here will be slightly moving to this side. Yes or not? Because that will be repelled. Okay? So it is normally without this molecule, this is neutral. This is non-polar. But as soon as this molecule is coming closer to it, it's becoming polar. थोड़ा सा हट रहा है मतलब क्या ये polar हो रहा है कि नहीं? Some partial charges will be developed. Okay? So it is gaining polarity induced by a polar molecule. Yes, this carbon dioxide is gaining polarity induced by a polar molecule. So if it comes like this will slightly become delta positive. होगा कि नहीं होगा? क्योंकि इसका इलेक्ट्रॉन जो है थोड़ा इधर जा रहा है. Yes, not normally when it is coming. Okay, and it will slightly become delta negative. Yes. Now this negative and this positive will attract each other. Will they attract each other? Yes. The molecules are attracting each other. What type of force of attraction we are going to say that? We are going to say it as dipole. Is it dipole? It itself is dipole. Induced dipole interaction. A dipole, one is dipole, another one is non-polar. But that non-polar molecule is becoming polar when the polar molecule is approaching towards it. But obviously that is very temporary. If you take out this, again it will become non-polar. Is it clear? So dipole, induced dipole. Now tell me, out of these two which you know, dipole-dipole interaction and dipole-induced dipole, you can very easily say that which one is stronger force of attraction?
The first one.
Obviously dipole-dipole interaction is the stronger force of attraction. दोनों में dipole है. इसमें तो dipole था नहीं, ये तो non-polar था, ये अभी polar हुआ है ना? That is because of the induction, it has become polar. Okay? And it became what? It became polar, and then the force of attraction is there. The next one, the third one is ion dipole interaction. Ion dipole interaction. From the word itself you can understand it. Ion dipole interaction means the force of attraction now is between what? Now is between one dipolar molecule. Again I am drawing here only. Okay, between a dipolar molecule and ion. Between a dipolar molecule, the dipole is there, H2 again I am writing, and the ion, suppose sodium ion, or it can be a negative ion also. Will there be a force of attraction between this O negative and sodium positive? That force of attraction between the ion and the dipolar molecule is known as what? Is known as ion dipole interaction. So it is between a dipolar molecule, a polar molecule, and the ion. The ion can be positive, negative, anything. Is it clear? Okay. Last one. Okay, two more. Another one we call the simple London force of attraction, or we call it London force of attraction. We also call it Van der Waals force of attraction. I will use the second term very often. Van der Waals force of attraction. Van der Waals force of attraction. What is Van der Waals force of attraction? Try to understand this. Now, try to understand this. Okay, I'm just trying to, write down, suppose hydrogen gas and a hydrogen gas. Okay, suppose hydrogen gas and a hydrogen gas. What is hydrogen gas? H2. It is H2, hydrogen gas, H2. So H is bonded with H. Clear? There are two bonded pair of electrons. Two bonded pair of electrons are there. And where those bonded pair of electrons will be present? They will be present in the molecular orbital. We have studied that, right? They will be present in the molecular orbital. Means space surrounding the nuclei where the probability of finding the electrons, now two electrons are there, is maximum. एक यहाँ पे हो सकता है, एक यहाँ पे हो सकता है. This is the space. Clear? Okay. Another hydrogen molecule is there. This is the space of it. This is the space of it where the probability of finding the electron is there. Okay. But we know hydrogen molecule is non-polar. So both the hydrogen molecules are non-polar. So if both are non-polar, there should not be any force of attraction. There should not be any force of attraction because both are non-polar, so there is no opposite charges so that they will attract each other. Then what is it actually? What is it happening? Now I told these two electrons can be within this space. Within this space. Now suppose these two electrons are coming towards this side at one particular moment. Momentarily. It can be here also. If these two electrons comes over here, then this side of the molecule, H2 molecule, is becoming to thoda sa negative charge. Momentarily, it is all moving. Okay? Momentarily it is becoming negative charge. As soon as this is becoming negative charge, iska jo do electrons hai, those two electrons are going to the other side because they will be repelled. So this side of that molecule will become positively charged. Yes? जब वो घूम रहा है, because the electrons are moving around the orbit. Okay? So this charge that is developed is very, very momentary. Very, very momentary. Okay? And because of this momentary, there will be momentary charge developed. There will be certain kind of force of attraction. And that force of attraction is called London force of attraction or Van der Waals force of attraction, which is obviously the weakest force of attraction. जितना भी पढ़े हैं हम लोग उसमें से this is the weakest force of attraction because this is very momentary and this is mainly seen in the gases. This is mainly seen in the gases, very weak force of attraction. That is why they are far apart from each other. Okay, fine. And the last one, that is the special one. I mean, in this class means class 11, you are going to have the concept of it simply. Okay. But the application, a lot of application we are going to do it in class 12. A lot. Even in class 11 also one or two applications we are going to do. But a lot of applications we are going to do it in class 12. That is called hydrogen bonding. The last one is called hydrogen bonding. Okay? That is actually nothing but a special type of dipole-dipole interaction. A special type of dipole-dipole interaction, which is the strongest till now, whatever we know. Till now, whatever we know, that is the strongest dipole-dipole interaction. But this is a special type of dipole-dipole interaction. What special? What special? There must be two conditions when a molecule will show the hydrogen bonding. What are the two conditions? The first condition, the molecule must contain the hydrogen atom. Please understand it. The concept should be very clear. The molecule must contain hydrogen atom. I am just taking two examples. Okay, one I am taking H2O, another one I am taking CH4. So the first condition is fulfilled by both of them. Yes, the molecule must contain hydrogen atom or atoms. Both of them has got the hydrogen atoms. Yes, that does not mean that if a molecule satisfies the first condition, it will have the intermolecular hydrogen bonding. No, hydrogen bonding nahi. There must be a second condition. What is the second condition? The second condition is that the hydrogen or the hydrogens that is present in the molecule must be directly bonded with the three most electronegative elements. Directly bonded with the three most electronegative elements, that is fluorine, oxygen and nitrogen. It must be directly bonded with the three maximum electronegative elements. Clear? तब क्या होगा? What will happen? Now what is the case in these cases? Out of these two cases, in one case hydrogen, just I am taking one bond, it is like this HOH, clear, in water. In another case it is what? It is CH4, right? CHHHH, yes? Yes or not? Both are showing dipoles. Both are showing dipoles. Clear? But here the charge difference is maximum. Why maximum? Because oxygen is maximum electronegative. So it is attracting the bonded pair of electron towards it to a great extent. So the negative charge that is generated is very high. And since the negative charge that is generated is very high, so positive charge that will be generated over here or here will be also very high. So the amount of charge is very high. So the dipole moment will be also very high. Because dipole moment is what? It's nothing but charge into distance. Yes? But in this particular case, the electronegativity difference between the carbon and hydrogen is not as high as that of oxygen and hydrogen. Here also charge will be generated. This will become delta negative, this will become delta positive because hydrogen is little electropositive. Okay? Than carbon. But it is not that the electrons will come towards carbon as it had come in case of oxygen and hydrogen. Did you understand? Why? Because oxygen is much more electronegative than carbon. Yes? So if it is there, now if I talk about the bonding between H2O and H2O, there will be dipole-dipole interaction. In between CH4 and CH4, there will be dipole-dipole interaction. Both will have dipole-dipole interaction. Because this is also polar, this is also polar, this is also polar, this is also polar. In which case the dipole-dipole interaction will be more? In case of H2O, because the dipole is more over there. That particular interaction is called specifically, a special type of dipole-dipole interaction as I told, is called hydrogen bonding. Now hydrogen bonding can be of two types. In the next class I am coming. It's less than 1 minute only. Okay, so next class I am coming.